All right, I am going to take you on a tour of the solar system, rather the life cycle of stars. Here we go. So stars begin, they are born in what we call a stellar nursery, and here's a picture of the Orion Nebula, a fantastic example of a stellar nursery. It's a huge, huge cloud of gas and dust out in space. It can be light years long, thousands of light years wide, it's just dust and gas that's sitting out in space. It could have been there for millions of years, and at some point it starts to collapse under its own gravity. Once it starts collapsing, these little pockets of more dense material start to form by gravity, and these will eventually aggregate, constrict, become smaller as they pull themselves in due to gravity and form a new star. Now, as we zoom in here, we can see what's actually called a proplet. This is a little region of this cloud that has become dense enough for a star to form within it. It looks like a little ball of dust and gas. It actually is. And inside this blob, a star is forming, and this blob will very likely turn into a planetary system. Whatever doesn't get blown away as the star forms and sends out its strong stellar wind will turn into planets around this new star. Once a star is formed, it then, well, the first part of its life is sort of this struggle between gravitational contraction versus thermal pressure as nuclear fusion's getting hold in its core, and it's sending out an extreme amount of energy which pushes out on the outer material, which of course is still being pulled in by gravity of the inner material. And you have a rather unstable star. There are lots of examples of these. They go through periods of outbursts and contraction and expansion, but eventually these protostars will settle down into a steady state where the nuclear fusion in the core exactly balances, creates a thermal pressure which exactly balances the gravitational contraction that's occurring. And we then have a star. Here's a picture of the sun from the Solar Dynamic Observatory. On the right corner you can see a huge solar prominence, and we will zoom in to the surface of the sun to see what is really going on in great detail. Here we go. Let's see if we can get some action shots going. You can see we're not able to see too much. We should be seeing these loops swirling and twirling. We'll have to work on that later. Maybe we can get some visuals going on here. So these huge loops of plasma are being ejected constantly out into space and then trapped in the magnetic field lines of generated by the spinning huge mass of iron at the core of the center of the sun. Okay. So a star does that for millions, billions of years, depending on the mass, the initial mass of the star. Many of these will go on for billions of years. Our own sun will fuse for about 10 billion years, but it will eventually run out of fuel to fuse, which then it will no longer be able to sort of fend off the gravitational attraction towards its center. Therefore, it will sort of lose hold of its gas. And here we see a bunch of planetary nebula, as they're called. These are stars at the ends of their lives that just sort of thrust off, reject matter as the battle between gravitational contraction and stellar fusion starts to pressure, thermal pressure, as this battle starts to fade. So they throw off these amazing shells of gas, and they can do it multiple times, and you get these fascinating shapes as stars are spinning, and sometimes their magnetic core or magnetic alignment doesn't match with their spinning, and you get these amazing shapes out in space. All right. Now this is an interesting example. This is the star Mira, and it's traveling to the right in this picture. You can see this star there, and what's happening is this is actually a red giant star at the end of its life, and it's just happens to be plowing through space at an incredible speed, and so as it puffs off these gases over millions of years, it leaves a trail of the gas behind as it plows through space, and the front of it is actually ramming into dust and gas that's in front of it. This is an interesting star because people have known about Mira for thousands of years. It's a really bright star in the sky. It's a variable star, so it changes brightness over a period of time. And it was only in about 2011 that astronomers looked at it with the Galix ultraviolet orbiting telescope and found this ultraviolet tail. Who knew? This star has been known for thousands of years. It had this giant 13 light year long tail. So anyway, this is an example of a gas giant at the end of its life just emitting these clouds of gas and dust. And once a star, we're stuck, there we go. Once a star has ejected all its material, it leaves behind the hot central core of the star, a white dwarf. A white dwarf, basically it was the hot inside of the star. The sun, for example, has a 5,000 degree surface, but inside, at the core, where all the helium and hydrogen fusion is going on, it's about 15 million Kelvin. So if you eject the outside off, you have this hot, dense core of material. And basically, the star that's left over, this white dwarf, is about the size of the Earth. So let's kind of review the size of the Earth compared to the size of the sun. There you have it. Here's the sun, and there's a solar flare, and if we zoom in, there's the size of the Earth. So consider taking all of that mass and squishing it down into the size of the Earth. So basically a white dwarf is a super dense Earth made out of the mass of the sun, everything that wasn't ejected in the Planetary Nebula. All right. And from there, you have this white dwarf. It's ejected off its material. That material gets incorporated back into future generations of stellar nebula or stellar nurseries, and hence the term cycle. This is the life cycle, because from the end of the life of one star, you get the material for the next generation of stars. Now, we just talked about the small stars, the 95% of stars that end their lives as planetary nebula, like our sun will do in 5 billion years. But what about the 5% of massive stars in the universe? Well, that's Chapter 2. Thanks for watching.